Hello everybody, we now come to the next chapter in physics, that is upthrust in fluids, which also includes Archimedes principle and flotation. Now, first of all we need to understand the meaning of upthrust, or we can call it as a buoyant force. Buoy, not B-O-Y, it is B-O-U-Y. This is nothing but a float. A floating body is called as a buoy. So a buoyant force is the force which causes the substance or an object to be floating. Okay, that's why it is called as a buoyant force, or the upthrust. Okay, upthrust or the buoyant force. So it is that particular force which is going to be acting against the gravity and making the body float. Okay, making the body go upwards. So each and every body, when it is made to go downwards in the water or even in air as such, there will be an upward force given by the air or the liquid in which we are going to drop that particular material. So that upward force what we are going to get is called as upthrust or the buoyant force. Now the example of this could be very simple, that if you take a tumbler and you put it inside water, okay, with not the hollow part up, hollow part upside down. So you got a tumbler, यहाँ पे हवा है, so you are putting it down inside, and when you press it inside and then you leave it, what will happen? It will just bounce back. क्यों bounce किया उसने? Because there was some force which is pushing it upwards. So that upward force which pushed the tumbler upwards, or else you all know swimming. So when you go for swimming, you have got a float which you tie around your waist. So that float what you're tying up, if you take a float and try to dip it inside the water, what happens to it? It bounces back. So it pushes itself upwards. So what is the cause of that upward movement? That upward movement is due to the upthrust. So upthrust is that upward force on a body. So when a body is partially or wholly immersed in a liquid, an upward force acts on it. This upward force is known as upthrust or buoyant force. It is denoted by the symbol Fb. So that is buoyant force. Force which is buoyant, which is Fb, which is nothing but the upthrust. Thus, the upward force exerted on a body by the fluid in which it is submerged is called as the upthrust or buoyant force. Okay, it is the upward force which is exerted on the body by the fluid in which it is being immersed is called as, or submerged, it is called as the upward force or buoyant force. Upward force or buoyant force, that is the force which is acting on a body due to the body being immersed or submerged in the water or the fluid. The property of a liquid to exert an upward force of the body immersed in it is called as buoyancy. Okay, buoyancy is that particular property of the liquid. The buoyancy is of the liquid. So liquid is going to be giving the buoyancy. That means it has got the tendency to exert force on the object which is being placed inside it. This property can be demonstrated by the following experiments. Pushing an empty can into water. Take an empty can, close its mouth with an airtight stopper, put it in a tube filled with water, a tub filled with water. It floats with a large portion of it above the surface of the water, and only a small portion is below the surface of water. You can see that when you put a particular, suppose it is a container and this is a water till here, and you take a small can, okay, or you take a can over here, you will find the can will be like this, partially which is inside the water and partially which will be above the water. So if you dip it inside, it will just pop out and come out like this, partially inside and partially above. If we push the can in the water, we feel an upward force which opposes the push, and we find it difficult to push the can further into water. It is also noticed that as the can is pushed more and more into water, more and more force is Buoyant force is needed to push the can further in the water till it's completely immersed. When the can is fully inside water, a constant force is still needed to keep it stationary in that position. Now that the can is released at this position, it is noticed that the can bounces back to the surface and starts floating again. So this is what you are saying, that if I take this can and I press it inside, so as I'm keeping it inside, there is a more and more amount of force, upward force given by the liquid. And if I submerge it completely inside, still, even if it is completely inside, I will not feel that abhi to pura andar chala gaya to abhi wo डूब गया. No, it will still have a tendency to go upward. So I'll be constantly having a upward push given on my hand, or through which I am pushing the can inside. And so much so that if I release my hand, that can is just going to bounce back upwards from the water. Similarly, pushing a cork into water. If a piece of cork is placed in the surface of water in a tub, it floats with nearly 2/5 of its volume inside water. If the cork is pushed into the water and then released, it again comes to the surface of water and floats. If the cork is kept immersed, our fingers experience some upward force. The behavior of cork is similar to the empty can. Now the float what you are wearing in your swimming pools are also made of cork. Similar material to cork, so that is the same thing. When you take that particular thing and put it inside the water, it is going to keep upward force, and it is very difficult to keep the float inside water. You need a huge amount of force which will be required to push that float inside the water for a longer period of time. So now let's see what is the explanation towards this thing. When a can or cork is put in the tub of water, two forces act on it. So let's see now. So we have this particular container. The container is filled with water up to this point, and inside this container we are putting a particular kind of this is a particular kind of a cube, or maybe just a substance. Now this particular thing over here is partially inside water and partially above the water, or we can keep it this way, that it's exactly above the water, exactly like this, means completely submerged. So this particular thing is going to act. There will be two forces acting on this particular body. One is the downward force, which is nothing but the W, that is the weight of the body. The weight of the body will always be taken from the center of gravity. From the center of gravity, there will be a force acting downwards, that is nothing but the gravitational force, which is nothing but the weight of the body. So mass into G, M into G, that is the force which is going to be given out, that is the weight of the body, which is going to be downwards. At the same point over here, there will be one force which will be upward force, which is nothing but FB. Okay, so that will be FB, which will be at the same point. We are going to get an upward force. That upward force is called as the FB, or the buoyant force, or upthrust. So the two forces act on it. One, the weight, the force due to gravity, that is W, which pulls it downwards, and the upthrust FB due to water, which pushes the can or cork upwards. It floats in the position when the two forces become equal in magnitude, that is W is equals to FB. Now as the can or the cork is pushed more and more inside the water, the upward force exerted by the water on it increases and becomes maximum when it is completely immersed in water. So when it is released, the upward force FB exerted by water on it being greater than its weight W, or the force of gravity, it rises upwards. To keep the can or cork immersed, an external downward force equal to FB minus W is needed to balance the net upward force. So you can see over here that if originally if I don't give any force at all and I just place that solid into the water, suppose it is like this, that it is going to be this way, that this much is outside water and this much is inside water. Now if I apply a force over here and make this thing completely submerged in water, so I am making it completely submerged in water. Now if we make it completely submerged in water, then I will require a force such that the W plus my force will be equal to FB, or the force required will be FB minus W. Okay? If the upthrust is, see, this is going to take place when the upthrust is greater than the weight of the body. If the upthrust is greater than the weight of the body will float. If the upthrust is less than the weight of the body, then the body is going to sink. फिर क्या होगा? It is not going to be floating at all. So it is just, for example, if I take a coin and put it in the water, is the coin going to float? No, the coin is just going to submerge inside and fall down or get into the deep into the water. Okay, but अगर वही जगह पे मैंने coin के बदले, if I take some hollow दिया or something मैंने अगर लिया होगा, okay, I take something which is hollow, or if I take something like I make a like a leaf, or maybe I'm taking a cork ka piece, okay, then when I put it, it is going to float upwards such that half of it will be inside water, half of it will be above the water, or not exactly half, but partly it will be inside the water and partly will be above water. So at such condition, if I want to keep it completely submerged, I will need to apply force which will be equal to force upthrust, what is there, minus the weight of the body. So the weight of body minus the upthrust minus weight of the body, whatever is the difference, that amount of force will need to be continuously given to it so that it keeps remaining inside water, submerged in water. Because the moment you are going to release this force, this curve is going to come back into a original position. That is, it is going to come back like this, wherein this much part will be above water and this much will be below water. So that's why we see that to keep the cork or the can immersed, an external downward force equal to FB minus W is needed to balance the net upward force. We need to note over here that like liquids, gases also have the property of buoyancy. So this particular property what we are seeing is not only in case of liquids. Even in gases we can see this property, and that can be best suited to us to understand how does the balloon rise upwards. Okay, balloon rises upwards. When I take a balloon and fill it with hydrogen or helium, it is going to rise upwards. But the same one which I filled up with air from my mouth, then it is going to come downwards. So you can see that the balloon is going to go upwards. That means there is an upward force, that is an upthrust given by the air also. Even the gases can give you an upthrust due to which the body is going to float upwards in air. So a body submerged or placed in a gas also experiences an upthrust. All objects including ourselves are also acted upon by a buoyant force due to air. But we do not feel it because it is negligibly small as compared to our own weight. See, if I told you, if the weight of the body is more, then it's just going to sink. So we don't feel the upthrust at all. Similarly, we are also given having upthrust, but we do not feel the upthrust because the amount of upthrust which is coming on our body by the air is negligible as compared to the weight of our body. Due to the negligible difference, we don't feel that particular thing, and that is why when we jump from a particular height to downwards, you don't feel like you are floating, you are going to fall down directly. Okay, because our body is not, the weight of the body is much more as compared to the upthrust what you are going to get from the air. On the other hand, a balloon filled with hydrogen or any gas lesser density than air rises up because upthrust or buoyant force on the balloon due to the surrounding air is more than the weight of the balloon filled with the gas. So when you're taking a balloon, then balloon has got a bigger volume, it has got gas filled in it, and the weight of that balloon with the gas filled in it is less than the upward force which is going to be given out by the air. The upward force, that is the upthrust given by the air, if that is much more than the weight of the balloon itself with the gas inside, then the balloon is going to rise upwards. Is it clear? So accordingly, we have the conditions. So with this, we get an idea that what will be the conditions for a body to sink or a body to float. So firstly, let us see this thing. So when a body is immersed in a fluid, two two forces acting on it. First thing is the weight W, I told you this, and on the body which acts vertically downwards, and the upthrust which is FB, which is acting vertically upwards. We have noticed that the upthrust depends on the submerged portion of the body. It increases as the submerged portion of the body inside the fluid increases and becomes maximum. That is F dash B. So when the body is completely submerged in the body, in the liquid, if the body is completely submerged in the liquid, then the buoyancy, that is the upward force of buoyant force, that is the upward force or the upthrust given by the water or that particular liquid will be maximum, and that is given as F dash B. So when this is completely submerged inside, the upthrust will be equal to F dash B, that is the maximum amount of thrust which can be exerted on the body by that liquid. When the body is completely immersed inside the fluid, as figure 4.1, show the body held completely immersed in a fluid with two forces W and F dash B acting on it. Depending upon the density of the fluid, the maximum buoyant force F dash B can be greater, equal to, or less than the weight W of the given body. When the body will float or sink, whether the body will float or sink will depend upon the relative magnitudes of force of W and F dash B, that is buoyant force when the body is fully submerged. So we have got over here the two things that we have the conditions. There are three conditions what you are having. One is if the W is greater than F dash B, W is equal to F dash B, or W is less than F dash B. Okay, these are the three conditions what we can have depending upon the type of the material and the type of the liquid what we are having. The fluid का density के हिसाब से there will be three conditions. One is that the buoyant force is less than the weight of the body, or the buoyant force and the weight of the body are equal, and the third is the buoyant force is greater than the weight of the body. So we see that if the F dash B is greater than W or is equal to W, so if these two conditions are there, the body is going to float. Okay, if F dash B is equal to W or F dash B is greater than W, the body will float, it will not sink. If F dash B is greater than W, the body will float partly immersed with only that much part of its liquid inside liquid, the thrust FB due to which becomes equal to the weight W. Now that we'll understand much more easily when we are seeing this part of this chapter, which is flotation. Or we can just say one thing, that when condition is this way, if this is the water part and the body is placed inside, when the body is placed inside, if the F dash B is greater than W, then only that much amount of the body will submerge inside water, which will be able to correlate to the FB for that much submerged part. See, we know that as you submerge a body more and more, the upthrust goes on increasing. Okay, so suppose I take this particular thing and put it inside water. So when I put it inside water, मैं जब इतना डालता हूँ तो upthrust इसके हिसाब से, it is based on this much volume. As I go further, then this much volume. As I go further, then this much volume. So as I keep on increasing, the upthrust keeps on increasing. As I keep on going, make this go inside the water more and more, the upthrust keeps on increasing. So for a floating body which is like this, where when it's completely submerged, if the FB1 is greater, F dash B is greater than W, then when I release it, at that time it will adjust itself in such a way that partially it will be inside water and partially will be above water. The part which is inside water, okay, the part which is inside water uska volume will be such that it will be able to have an equilibrium with the weight of the body. So that means at the floating condition, it will be such that even for this thing, W will be equal to F dash B. That means it will be FB, not F dash. F dash is the maximum amount of, see, F dash B is the maximum upthrust that is available to us when the body is completely submerged. When the body is completely submerged, at that time, that particular body, so when the body is completely submerged, at that time the FB, that is the buoyant force, is maximum and is given by F dash B. But the moment it is partially inside, it is not F dash B, it is just FB. What is FB? That is the buoyant force according to the volume which is inside, which is submerged inside the water. So it will manage it in such a way that when the body is freely inside water without any upward force by any person inside, then the W and FB will be equal. That means only that much part of the body is going to submerge inside the water, which will be equivalent to balance the weight of the body. I am sure it is not so easy to understand this way, but as you go ahead in the chapter, and when we understand the basic factors on which the upthrust is going to depend, we will be able to understand this much better. And finally, when we see the chapter part flotation, automatically this will be completely clear to you. Anyway, you try to understand things to the best possible right away, and then we will discuss this thing much more. So we can see here that if F dash B is greater than W, or F dash B is equal to W, the body will float. That is, it is not going to sink. If F dash B is greater than W, the body will float partly immersed with only that much part of it inside liquid, the upthrust FB due to which becomes equal to the weight W. Okay, so that is what I told you, that it will submerge this part when I put inside water will submerge, only that much part will submerge, wherein the FB which is produced by the submerged part is equal to the weight of the body. Okay, this W, so we saw that this W which is there, here W, and the FB which is we are going to get over here by this much submerged part over here, this is FB and this is W, and W and FB will be equal. Hence this much part will be inside water and this much part will be above the liquid or water, not a problem. So I'll read this thing once again because it was quite confusing, that's why. The body will float partly immersed only with, so that is, if F dash B is greater than W, the body will float partly immersed with only that much part of its inside liquid, which is the upthrust FB, due to which becomes equal to the weight W. Okay, it will submerge only that much part, for which the FB will be equal to W. But if F dash B is equals to W, then the whole body will float with the whole of it immersed inside the liquid. Thus, for a floating body, net force acting downwards, that is apparent weight, is 0. Okay, so you can see here that if this is the condition, then it will be such that the body is going to be floating. But how will it be floating? Such that if this is the water body over here, this particular body will be completely submerged in water. Okay, this will be completely submerged in water, and such that the W will be equal to F dash B. W will be equal to F dash B. In this case, this is the condition. W is equals to F dash B, and the body will be completely immersed in water, but it is not going to sink. The water is over here and the body will be over here. Right, but it is not going to sink down. It is just going to remain inside the water, but completely submerged. But at the same time, it is not going to sink, so it will be floating. So Thus, a floating body net force acting downwards, that is apparent weight, is zero. So this you can see that when such a thing happens, what has happened now? The W is acting downwards and FB is acting upwards, and if W and FB are equal, so what is the net force on this body? The net force on this body is zero. And that is one gives you a very good example of the fact that if you are playing in a swimming pool, you will find that in the swimming pool you can carry, you can lift even a person who is double your weight. If you weigh 40 kgs and somebody is weighing 80 kg, in the swimming pool you will be able to lift him. Why? Because if that body, if that 80 kg person is floating, then his net weight is zero. Okay, the net weight of any floating body, the net weight of any floating body is zero. एक बड़ा सा शिप है, वो बड़ा सा शिप जो है वो पानी के अंदर फ्लोट हो रहा है, it is not sunk inside the soil, it is floating on water, then the total net weight of that particular ship is zero. I know it's very amusing, it's like mind blowing. Okay, it's amazing thing that, but it is true. Any floating body you take, okay, the floating body ka net weight will be zero. So that is the most important part over here, that when you say any floating, now that is a very good example for this thing, but then I'll just complete this part and then I'll discuss that part. In the second case is, if F dash B is less than W, the body will sink due to the net force W minus F dash B acting on the body downwards. If M is the mass of the body, it will go down into the liquid with an acceleration A much such that A is equals to M into A. So W minus FB, or A is equals to W minus B upon M, where we have ignored the viscous force of the liquid. So what they are going to say is that the acceleration with which we know that F is equals to force is equal to mass into acceleration. So accordingly we can see that mass, we know over here, is going to be constant, and acceleration, mass and acceleration, what are over here? The mass into acceleration will be W minus FB. W minus FB will be equal to the total mass, because upthrust के कारण mass थोड़ा कम हो गया, and that will be, so acceleration will be equal to W minus FB upon M. So of course we ignore the fact that the density के हिसाब से, viscosity के हिसाब से, the liquid is going to give you some more upthrust, which we are not considering right now for this particular example. Anyway, not too important, but this is just a fact that okay, such a thing could also happen, because viscosity के कारण, the viscosity, the thickness of the material के कारण also there could be a possibility that it could not fall immediately downwards, but it is like going in a slower manner because of the viscosity. Okay, so anyway, that's not important for the chapter as such. And the unit of upthrust is the upthrust being a force is measured in Newton or kgf. Right, so that is important. So upthrust is the same as the thrust or Newton or kgf. Now I was just telling you about the fact that what is the importance of the weight being zero, net weight of that particular body or floating body being zero. Now in a place near Germany there is a bridge which is a water bridge. What is a water bridge? There is one river over here, and there is land in between. So what they did was, they have made a bridge such that there is a bridge coming from this water body to this water body, and the ships can travel from here to here, and from beneath there could be cars which can be moving around. So there is a bridge over there which is present over there. Now when the engineers wanted to design this particular bridge, it was very difficult for them, because they didn't have the idea that कि अगर by chance वहाँ पे इतना जो bridge बना, now bridge always needs a load bearing capacity, कि कितना load ले सकता है. अभी जो bridge उन लोग ने जो बनाया, उन लोग के load bearing capacity के लिए उन लोग वही सोचते थे कि there could be tons and tons of the material coming from one ship. You can see the ships which are the cruise ships, which are almost like 10-story building, and then there are cargo ships which has got containers and containers of load. Now how can you make a bridge which could be taking the load of so much huge capacity of the ships. But then it was this particular principle that the floating body ka mass is, or the weight, the net apparent weight of the floating body is zero. This was the thing what was applied in that particular bridge ka construction. So they came to know that if you have a bridge over here, so suppose you have a bridge like this. So suppose this is the water body and you have another water body and there's a bridge over here like this over here. So this is the retaining wall and the cars can go from here. So if this is the ships which are going to travel from here to here, the ships are going to travel like this. They can see that what this ship, however big it is, kitna bhi bada ship ho, what is the weight of this body? The weight of this body is zero. The net weight of the body is zero because whatever is the W acting will be downwards, there will be equal amount of FB which will be there, which will make the net force given by the body to be zero. Similarly, so what is to be measured over here is that this particular bridge is going to take the weight of the water. So it's the only amount of water. The bridge construction was done in such a way that the only load bearing capacity of that particular bridge was the weight of the water which is going to be present in that particular bridge. वो bridge के अंदर जितना पानी fit हो सकता है उसका weight, the weight of the water which is present inside, that is the only load which this particular bridge is going to take. The bridge is not going to take any load of any of the ships which is going to travel on that particular bridge. Okay, so that was something I will call it as a engineering miracle due to which that bridge was made. You can even Google through that. It is some water bridge or something which is called over there. It's water bridge. There are very nice photographs of that, wherein there are two water bodies and the bridge is going there. Then नीचे से गाड़ी जा रही है, ऊपर से ships जा रही है. So that's a very nice thing. You can see that thing. So that was about the initial part of flotation of the upthrust. Now we see the characteristic properties of upthrust in the next video.